right, peoples. So we're gonna talk about NIST. I'm sure if you guys are into cybersecurity, or if you guys are looking into cybersecurity, you're wanting to see what it's all about. Um, Here is a good example of what cybersecurity, I would say, on the non-technical side, right? But and just it has its tentacles into everything. Um, of cybersecurity is right. So if you're like thinking, okay, I want to get into cybersecurity, I want to know what it's all about. I'm going to give you a good little prime example of what on a higher level what cybersecurity is. Um, right now, I'm looking up NIST SP 882R3. Okay, and this one's a little bit different from NIST 853, but it's in collab with it, right? So um, so let's do this. If you're one of those guys that you're new to cybersecurity, but you want to know what it's all about, um, this is part of it, right? So this would be setting up frameworks and policies and procedures, and give you an idea on how to protect the system, right? Um, if you don't know what NIST is, I mean, it's the National Institute for Standards and Technology, and see, National Institute of Standards and Technology, U.S. Department of Commerce. It's a it's a government entity that helps create cyber policies and helps other companies have a guideline for cybersecurity policies. Okay, it's a great resource. A lot of companies use it. Now, there's many different guidelines. There's NIST. There's ISO, or if it's ISO, I can't remember. There's a bunch of different frameworks for different, um, recommended for different entities. I say entities because it can be, it could be an organization, or an entity that's, let's say, like healthcare. It can be education. It could be industry. It could be industrial. It can be all these different entities, right? That are going to need different things to protect and different strategies on how to protect them, right? Because they're different things. They have different things to worry about. Like your medical has um, the Protection Act, right? Information Act and stuff like that that they have to worry about, where they have to keep patients' information confidential, right? I think it's called PCDI or something like that. I can't remember. But anyways, it has certain things that are more important than others, right? And so you're going to follow a framework that supplies that and focuses heavily on one area, maybe, right? And so, and a lot, so everything's different, right? There's credit card information that needs to be, like credit card companies, banks, they have all their information too, so they need to have different guidelines. But they're all basically have one goal, and it's to protect an organization and ultimately people's jobs, right? There's a noble cause in cybersecurity because what you're doing is you're setting up and keeping a company safe, or the company you work for safe, which is protecting your job and everybody else's job, right? If a company gets hacked and they have to spend ransomware or whatnot, they might not be in business, so they might have to let people go. And so it's a noble cause, cybersecurity, right? And that's one thing. This one right here is specifically is the guide to operational technology, right? Security. So operational technology, okay, and you think, what is that? What's the difference between operational technology and information technology? Because they're so intertwined. They're trying to intertwine them now and make them converse with each other, right? You know, have to deal with each other, right? And so more so than before, because a lot of these new physical operating systems are getting more high tech by the day. And so what we can do is we can look at this. This is just an off branch that's protecting physical systems, right? And things that have effect on the real world. So let's take, for example, let's take like a potato chip factory, right? It's got conveyor belts, it's got sensors and PLCs and all this stuff. I don't know if you're familiar with that field, but it's got all these equipment, right? That processes the potatoes, right? It's called a processing loop, control processing loop, and those have to be protected too in some way, shape, form, or fashion, right? Because if somebody can come in and hack one of your PLCs and blow up your equipment. Somebody can come in and have access to the physical system, upload a virus. You're done. Um, and then there's the IT part of that, right? That the data management process part of it, or and stuff like that, right? In your transmission and stuff of data, right? And the IT manages data processing, applications, software, and all that, and it's the network, right? Your IT is handling the network, and it's usually connected to these physical systems. Okay, so this is where the guide to operational technology security comes in, right? So now you're going to try to converge both of them together, and then you're protecting your physical systems. A while ago, I guess the INL out here in Idaho created a virus and uploaded it on the IT side, compromised the IT side. And it was called the Aurora vulnerability, I think. That's what it is. You might want to Google it. But they created it to test to see what can be done from the IT side compromise into the physical systems. And they uploaded a virus on the IT side, whatever, and it was able to affect a physical system that it was connected to out in the field, and I think it was a generator, and blow the generator up by misfiring making it go on and off constantly and misfiring, and then just smoked and blew up. And so an IT vulnerability, right, like a hack, right, once it got into the network, was able to effectively destroy $1 million equipment and possibly harm physical people out in the physical world, not just cyberspace. Okay, so there's a difference between cyberspace, or I would call it cyberspace. And it's all digital information, to taking that digital information and actually having a physical effect, and where you're blowing up a physical device and possibly harming people, right? And physical people. So you're taking out of cyberspace to the real world, and that's what basically what OT security is. And this is an awesome reference, NIST 882 R3, and I've been reading this, right? And I'm not gonna go through and read this for a video. I just wanted to make a quick little 30-minute video on resources. And this is so great that once you start reading this, I've been reading this just like a damn novel. I love it. So you go through this, and step by step tells you, because I'm in this field. I'm more into this field, right? I was an electrical engineering technician. I used to build and repair and maintenance all this equipment, and then I also I got the software, so I can get into the monitoring process of it, or the SCADA, SCADA systems and stuff like that, whatever. And then I got into cybersecurity, so then you can get into the cyber side, which is this part of it, right? And um, if you get through this, I mean, it goes through like your executive summary, right? Which is awesome. You read that and get some kind of knowledge. So we'll start right here. Okay. OT cybersecurity programs should always be a part of the broader OT safety and reliability at both industry sites, enterprise cybersecurity programs, because cybersecurity is an essential to safe, reliable operation, yada, yada, yada. Threats to OT systems can come from numerous sources, including hostile governments, terrorist groups, disgruntled employees, yada, yada, yada. Possible incidents that an OT system may face include blocked or delayed flow of information, right, through OT networks, which could disrupt OT operations, including loss of view and loss of control. Right? Unauthorized changes to instructions, commands, or alarms thresholds that could damage, disable, or shut down equipment. This is what I was talking about. Create environmental impacts and or endanger human life. This is exactly what I was talking about, right? Inaccurate information sent to system operators, either to disguise unauthorized changes or cause operators to initiate inappropriate actions that could have various negative effects. Now, this would be on like the SCADA systems or the monitoring systems. I used to build these monitoring systems for a company, and this is what they do. They basically take readings, and I don't know if you can cause changes and stuff and with our software and all that, but I don't remember if we could or not. But it sure does have readings and monitors and have effects on stuff. So if you can hack that, you might be able to do something in the physical world. Modify OT software configuration settings or OT software affected with malware, which could be various negative effects, right? Same thing. And this just gives you examples, right? So major security objectives for OT implementation. So if you're trying to set up an OT framework, it gives you like what to look for, right? Here you go. And here, restrict logical access to OT networks, network activity and systems. So when I worked for a place where we had now this is for the network, right? It says this may include using unidirectional gateways. So we had hold on, utilizing DMZ zones, firewalls. Let me see if this one, yeah, separate authenticated mechanisms and credentials for users. So we used to have the physical doors where you had to use a card to get in, badge in, right? That could be one. Restrict physical access. Well, that's more of what I was talking about. Protect individuality components from exploitation. Restrict unauthorized modification of data. Protect security events. I mean, these are just basics, right? But then it goes on, and then tells you like what OT is versus IT. Tells you the purpose of the scope. You keep coming, and then OT-based systems and their independencies. Government facilities could be food and art agriculture. Could be nuclear reactors, and this is what I used to work on right here: nuclear reactors and material. And then this is a lot of food and agriculture up here in Idaho. There's tons of food and agriculture companies that need OT people, um, because they have a lot of you know um, equipment that's hooked up to the network, to IT. OT systems operation architectures and components. Here's just a basic, human. Here's your HMI, human machine interface, controller, actuators, here's your control process, sensors, remote diagnostics. Just how it works, and it just goes on and on. This is a great resource. Okay, I've been reading it like a damn novel. I mean, it is just beauty. But to see, that's the thing. Like I've been in this field for a long time, right? So I've been at least 10 years. To I would say, yeah, it's 2015. I've been studying it since 2012. So I went to school for double ET, which is electrical engineering technician at Idaho State University. And so I've been studying electrical and this kind of equipment and components for I would say 12, 8 plus 4, 12 years now. And I love them, right? I love it. It's in my blood now. Industry systems, industrial plants, nuclear power plants, and stuff like that. It all interests me. And so reading this just gives me way more insight to how it works and how to protect it and what equipment is used, and I've built all this stuff. I've physically built this stuff and wired them together, right? And then other people would, configure the software and all that, right? Of whatever they were using to control, like the SCADA, right? SCADA system, or the DCS system, or the just depending on what they were building, right? And you go, if you don't know what I'm talking about, you go through this and you'll get a better understanding. Reading something like this, if you know nothing of it, is not going to hurt you. It's not going to kill you, especially if you're trying to get into cybersecurity and you're like, and you want to understand on the component level, on the device level, what you're protecting. Now you can understand networking, and you can go get your CompTIA, and then you go, oh, okay, yeah, I know about that. I know what what CIA triad is. I know what uh, the 7-layer OSI model. I know all. I know what TCP packaging is or packets are. I know you can know all that stuff, and you got to know it if when you're in the industry, you got to know how to deal with it and read it and set up firewalls or whatever you're doing, right? I don't know. There's so many parts of the field studying for it. But if you don't have a clear view of what it is physically you're protecting or connected to, or what industry you're in, you got to know what industry you're in. You got to know what your network is. You got to know what what it is that you're protecting, right? So let's say you do work for a potato factory out here in Idaho. I'm using that example. There's a ton of them. But you've never been in the field. You don't know what an EET is. You've never repaired or fixed anything, but you've gotten into cybersecurity. You've got your CompTIA. You know what networks are. You got your your little certifications and stuff, and you're like, I'm ready to rock. But you don't know any of the physical systems. You have no clue of what you're protecting. You don't know how it works. You don't know even how it would even be wired up. You've never heard of what a PLC is. You don't know what an HMI is. You don't know what you barely know what a server is. I mean, so something like this would help you get an understanding of what you're protecting in the physical world in the industrial organization like that. And you don't need to know what every single one of these things does. Like, if you don't know what a PLC is, Google it, right? It's a programmable logic controller. You don't know how to wire them. You don't know how to program them. It doesn't matter. You know how they function. You know where their vulnerabilities are, and you know how to protect them. Those are the things you need to understand, right? If you're looking at that PLC. So right here is showing that this PLC is connected to a sensor, another sensor, and another sensor. These are sensors. That's a level sensor. So basically, it's leveling. It's checking to see if something's level. Sends it back to the PLC. PLC is connected to your communications module that is serial radio based communications. So is this hackable? Absolutely. If it's connected to the network, if it's Bluetooth, this is where, if I was getting into cyber, I'd be like, oh, this is where our problem is right here. Look at this. Serial radio based communication. Maybe if I'm able to hack that communications module, Now it's going to a server that's connected to the data historian. I'm sure that, and then you all this stuff and engineering workstation, and then oh look, it's connected to the damn internet, right? It's a WAN. That means that it's probably connected to other regional, exactly, regional control centers. WAN is huge. It's going to be for a bunch of different data centers or control servers, right? So this is literally connected to a WAN that's connected. So this is a vulnerability, right? So you're looking at all this stuff, and this is mostly physical stuff, right? Physical, 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 physical. So that's the difference between OT and IT. Now a lot and you might get into cybersecurity where you're just looking at you're looking at data historians, or you're looking at workstations and servers and stuff, and really nothing physical. And that's more IT, right? That's more on the IT side. When you're dealing with OT, you're dealing with some physical systems that actually have um, impact on the real world. So let's say this sensor goes bad, right? And it's connected to a machine. That if it overflows, or if that level sensor is not working, or you get it to blow up in the redundant one or whatever, and your heater core, let's say to a nuclear power plant, I'm just saying, um, but the nuclear power plants have so much security and stuff like that. So, but what I'm in redundancies. But what I'm saying is, let's say it didn't, and it didn't shut off, or it didn't sense that there was water, and you burned a core, right, or something, right? So then it would overheat and blow up the whole plant. I mean, you'd have a nuclear meltdown. I'm just saying on the worst part, right? On the smallest part, that level sensor could be compromised and overflow. Yeah, it could even overflow, because if the sensor is supposed to stop when it's filling up a tank, whatever, it can overflow a tank and then just potentially damage equipment. Maybe steam burn some people and stuff. So, I mean, these are physical uh, uh, things that can happen when hacked. So that's the difference, and it's just so cool, right? So go through this. I recommend people that are trying to get into the cyber field, that want more hands-on, or have more hands-on, then maybe they know what all this stuff is. They know what a PLC is and all that, and they know what sensors do. Maybe they're double ETs or something. This would be the side that you want to look into if you're getting into cyber. So I've seen a bunch of positions for OT cybersecurity people now, and I love it. I think it's fascinating, right? Because these are the systems that like I said, I've been around my whole life. So I mean, my whole professional life, after college career, and this is a guideline on how to protect them, right? So yeah, well, that was hack the file, and this was just something different, something OT and IT. Google that, see what's different, what the difference is. Cybersecurity is a fascinating field. It is ever growing, and this is one more, I would say, position that I am seeing out in the field now. A lot of these industrial companies are steering away from hiring traditional IT people, and they're more looking to hire OT people. And I would say you don't really have to have experience per se in uh, uh, operational technology or out in the field. But I mean, in the industry of physical systems, like conveyor belts and all the and steam boilers and for potatoes or whatever, to understand the difference, and understand how to protect them, right? You would read something like this, or you would get a degree in it. There are physical systems degrees, and I think ISU is right now one of the only ones that actually is offering an operational technology degree in protecting these systems, because we have nuclear and so many potato factories and beet factories out here, a lot of agriculture and a lot of nuclear, and those are physical systems. So, cyber physical systems. So, I mean, but if you go anywhere in the country, I can guarantee you a lot of these industries that are going to be needing OT people instead of IT guys, right? And it's just fascinating. Cybersecurity is constantly growing. Now, this is the first I've heard of it. Like, I saw this degree at ISU. I teach at ISU part time, and I actually teach this program, the physical systems intro basic program. And well, I just barely started teaching it. I just barely started, like last month or 3 weeks ago, actually. So I haven't been teaching it for long, but that was the first time I ever heard of the program. Is when I even applied for the job, and this was like last year. I applied for the job, and it's a new program, and I don't know if it's a new concept, but I think it is a new concept because um, uh, I've never even seen this NIST 82 publication. Now, it's probably been out for about 5, 10 years, maybe, but it's starting to get where these companies are hiring for OT people. So just something to look into if you're getting into cybersecurity. It's just yet another rabbit hole to jump down in cybersecurity that is basically Hydra and got its damn tentacles in every section of everything, right? So, all right, it's been Active File. If you learned something, let me know. If you enjoyed yourself, let me know. Have fun, and I'll see you on the next one. Enjoy.